Yes, class. So in the last class, we had completed few questions from projectile motion. Some questions were left from this topic. So let us directly start with the questions then. As some of the time got wasted also in this meeting joining, some technical errors were there. I'll note down the questions. So till here we did. These 7 questions we were able to do. All right. So I hope you all remember the formula. Let's practice these questions because from tomorrow we have to start with Newton's laws of motion. So I'll note down the question, note it down, try it, send me the resultant option. Did we do that momentum question class? Questions on momentum we haven't done, no? Momentum which is related. All right, let's practice that then.
Excuse me, ma'am. Can you enable the chat system?
You people are not able to send the chat. Just a minute. Class, please confirm. Are you all not able to see the chat?
No, ma'am.
Okay, till that time, the team is working upon that. Let us discuss the solution. So, just directly tell me in the chat column, had the chat column been there, what would have been your answer? I think Saifulla wanted to give a try. What all answers were you getting? Which option?
I got C, ma'am.
You got C. Any other option by anyone? Saif is right. It is option C only. See, how can you solve this question? There are two methods to solve it, but first one is very easy and that will be helpful in your upcoming lessons and your work energy in power also. See, it says that particle of mass m is projected with the velocity v, making an angle 45 degree with the horizontal. This is the particle mass v. This is horizontal, this is vertical, this is angle 45 degrees, right? When the particle lands on the level ground, magnitude of change in momentum will be what? See, if we resolve this, now once it will come, here what will you be having? If you resolve this, this becomes V cos 45 degree, right? And this is sine 45 degrees J cap. This is I cap, right? If it is coming down, this is saying, no, the magnitude of change in momentum when the particle lands on the level ground. See. So same thing, we'll resolve this across x and y. So this part you have, this part you have. Again, this is cos theta for you. 45 degree it is making an angle V. This part will become V sine theta. Just a second. All right, even if you resolve it on the opposite side, that will also be V cos theta, V sine theta. Now, instead of doing this, what we have to do, we have to have an initial velocity. We have to have a final velocity, right? So final, this is initial velocity u is initial velocity, and v is the final velocity. Now see, even if you do not resolve this term, even if we do not resolve it from this side, what will we be observing? See, this component will remain as it is, but what will happen to the sine component? The sine component, this will be reversed now. This will be sine 45 degrees. So this will become minus j cap. Right? It will go in the downwards direction. Rest of the things will remain same. See, velocity will also be tangential. This will also go along cos theta only. So instead of writing all of these, it's better if we directly write it as two methods. I'll tell you. First is change in momentum, mass into final velocity, initial velocity. What is the definition of momentum? Mass into velocity. So it is v minus u. So this becomes, if we take mv common, so that cos theta and sine theta can be put. Initially, it's v cos theta. So cos 45 degrees I cap minus finally it is sine 45 degrees j cap. Right? This is how we are getting our answers. Or even if you want, you can, and this is the initial part, right? This is the initial part. And finally, what is happening? Finally, this is initial part. This is when it was going. Now, when it is coming, so what we'll do? We'll subtract. Let's write mv again common. So what will happen? Cos 45 degree I cap will remain the same, but now minus into minus. That is, this will become plus sine 45 degrees for the j cap. So this will directly, instead of writing this also, terms will get cancelled basically. Or you want, you can see it like this. 2mv sine 45 will remain because cos will get cancelled and sine will only be remain the same. So that is root 2 mv. Another method which I was saying, no, alternative method is that you can take the change in velocity separately, or you can take the change in velocity separately across y-axis, because across x-axis it will cancel each other. So across y-axis, if you will take, this is whatever will be, this is change in velocity across y-axis, right? Delta v. So that is, if you write it as 45, cos 45 and sine, same thing. So v by root 2, that time you will write minus v by root 2 you will write, because this is the change that occurs. So this becomes 2v by root 2, or you can write it as root 2v also. Same thing, momentum will be to change in velocity, that is mv root 2. Same thing, you will get it. But it's better if you resolve it. And more questions of this we'll see in work energy in power. When a momentum body will be hitting this, it will be moving. Same way, we'll be resolving the velocities here also, we'll be resolving the velocities here. All this cost will get cancelled and sine will be left the way it is. Note it down. Chat section is still not visible, no class?
Yes, sir.
Okay, anyways, note it down. I'll write down another question till the time others who have done, they can solve it. Plus, all of you, please rejoin. The chat column is not visible, no? All of you rejoin. Then please check whether it's visible or not. All right. All of you rejoin, please.